Hi, this is your video for the Charging Methods Demo Lab. Okay, I'm going to start with a piece of tape got here, and I'm going to stick the tape on this shelf right here. Okay, then I'm going to get another piece, and I fold it over the end so I can pick it up later. And I'm going to stick this one on the top of that one. Okay, and now I'm going to pick them up off the shelf, and they're stuck together, and I'm going to pull them apart. And what I want you to see is that they're attracted to each other. You see that? Okay. This one was on the top, and this one was on the bottom. I'm going to now stick them here on the shelf. Oops, there. Okay, now I have a balloon, and I'm going to charge the balloon by rubbing it with some wool fabric. You can do this by rubbing it on your hair. It'll get charged. You can stick it to the wall or something, but I can see after I do that, it's attracted to the left one and repelled by the right one. Attracted, repelled. A charged balloon has negative charge. So the left one must be the one that's attracted to it, must be opposite of that or positive, and the right one must be negative, and I'm going to label those. Okay, so I labeled them. I hope you can see plus and minus. When you rub a balloon with a piece of wool, the wool actually gives off electrons onto the balloon. And so it's like the balloon material, the rubber is scraping electrons off the wool. And one becomes negatively charged, the other one becomes positively charged, and we call that separation of charge. Here's another example. Let me move this. Here's a piece of plastic, and I'm going to rub it with this packing foam. Okay, now plastic's an insulator, so only the part I rubbed, you're going to see that it repels the one on the left and attracts the one on the right. Okay, so another question for you is, what about the wool? I rubbed the wool on here, right? So now, what charges the wool? And you can see that it attracts the one on the left and repels the one on the right. It's a weaker force, but that's what it does. Okay, if you haven't already, you should stop the video and answer the questions and draw the pictures for the first two sections of the lab. The tape electroscope, which is these tapes, and separation of charge, which is one thing rubbing on another to separate the charge between them. Okay, do that, and then I'm going to go on to part 3. Okay, now I'm going to use this thing which is we call this an electrophorus, because it's got an insulator and a conductor taped together. All right, and what I'm going to do is I'm going to charge the plastic. You see that? Charging the plastic sheet. All right, and then I'm going to just set this on the charged plastic sheet. And now the conductor, let's say the plastic sheet has a particular charge, either positive or negative. You found out what it was. Okay, let's say that the charge on the plastic is negative. I don't know. You know what it is, but let's say that plastic is negatively charged, and it's an insulator. I put this down on it. This conductor separates its charge, because charge can flow on a conductor. If the plastic is negative, negatives will flow away from the plastic. They're repelled, and positives will flow down toward the plastic. And so the charge on this conductor will separate top to bottom. And then when I just quickly touch it here, I become a ground, and I'm going to allow the charge that wants to go away, which maybe would be negative. I think it might actually be the opposite, though, to leave. And so then this thing is left with what's left, the charge that had stayed at the bottom, that didn't flow off my finger. And so this becomes charged. So let me just show you how that works. I'm going to charge up the plastic. I set this down. Ooh, I got a little shock. Now this is charged. And when I hold it up to the tapes, well, you can't really see, but it's attracting the positive and repelling the negative. Okay. Okay. in case you couldn't really see that, here it's attracting the positive, repelling the negative. Hopefully you can see that now. Okay, we call this process polarization with grounding. I'm just going to go over it again. When we charge this insulator and then set this down on it, the conductor, the metal, becomes polarized. That means the charge separates. And whatever charge the plastic is going to go away from, because we know likes repel, like charges repel. So that kind of charge is going to go up. And so if I touch it, I get a little shock, and that kind of charge goes on to me. Whatever's left is what charge this becomes. And we call that, again, polarization. That's the separation part. With grounding, that's when I touch it. Okay, now I have a second electrophorus here. It's got tinsel on it. And what I want you to do is watch the tinsel really closely. I hope you can see what happens when I charge the second electrophorus from the first electrophorus by conduction. That means touching. So the charge can actually flow. And I haven't charged this yet, but I'm about to do it. And I'll show you what that looks like. Okay, now I'm charging the plastic by rubbing it. This is separation of charge. And I'm going to drop this on here. Got a little shock there. And now watch the tinsel very closely. Did you see it opened up and separated? So what's going on there? I want you to think about what just happened. Okay, so in that case, I actually charged the second electrophorus. But I could also, rather than charging it, by the way, every now and then I touch something metal to discharge it, so that's discharge. Rather than charging the second electrophorus, I could just bring this, if I charge this and bring it close, I could just bring it close, and that would cause polarization of charge on the second electrophorus, and I should still see the tinsel move apart because I'm going to have a bunch of the same kind of charge on this side, and also the same kind of charge on this side, right? The kind that's attracted to this one is going to be on this side, and the kind that's repelled from this type is going to be on that side. Let's see if we can see it. By the way, it's very difficult to do these experiments in general, but it's even more difficult in the current weather we have right now, which is pretty humid, so things don't hold their charge very long. Okay, I'm charging up the plastic. Gonna drop the electrophorus. Got a little shock. And now I'm just gonna get close and see if you can see the tinsel move a little bit. It's hard to see. But anyways, that's the idea. You should see the tinsel spread apart as well on that one. Okay, now I'm going to show you a couple of different devices used in electrostatics. This was back in the day. These were high-tech instruments. This is called an electroscope, and what it is a conductor. Conductor going all the way through. That's a rubber stopper. Sorry, there. But going down to conducting leaves inside. So those are just like little pieces of aluminum foil. They used to be gold foil. And the idea of this thing is kind of like the tinsel, where if the two leaves were charged, you'd know it because they'd separate. They'd be repelled by each other. So, and the other device I want to show you is this Wimshurst machine, which separates charge on the two sides. So if now I have positive on one side and negative on the other, if I bring them together, you get a little spark. And you can kind of continually make charge kind of spark across if you, get them close to each other. There, you can see it just sparking across. Okay, so, and now I thought I'd use the Wimshurst machine to charge the electroscope in a couple ways. So here I have some kind of charge on this side. I don't know what it is. And I'm going to bring this electroscope near. And whatever charge is not that charge is going to be attracted to it. And whatever charge is the same as that charge is going to be repelled and is going to go down onto the leaves, causing them to separate when I bring it close. I don't know if you can see that. The other way you could cause them to separate is if you actually put that charge on here by touching it. You see that? It's pretty dramatic. They really separated. I hope you can see that. Okay, so that's another way to do it. And a third way to separate these two leaves, let me just ground it, is if you have it, the Wimshurst machine has some charge on it, and you bring it close, and then while it's close, you ground it. Then the charge that wanted to come up is going to leave on my hand, and whatever's left is going to be still there. So this thing is actually charged, and the two leaves are repelling each other a little bit. I don't know. Hopefully you can see that. Yeah, so there's still some charge on there. So those are the three ways you can cause the leaves of the electroscope to separate. Two of those ways are actually putting charge on the electroscope, and one of those ways is actually not. The total charge is still neutral. It's just that you've polarized it. And so I want you to write about those three different ways and which one is called conduction, which one is called induction or polarization, same thing, and which one is induction with grounding. Okay. Okay, this is the last part of the lab, demo lab. And I charged up the plastic, and I've got this little loop of tinsel. I'm just going to bring it close, and you can see, wow, it's really attracted to that charged. Even though this isn't charged, uncharged things are attracted to charged things. And that's an interesting, I'll mention that in the lecture. The other thing, though, is if I charge this electrophorus, I'll drop the electrophorus on there. Okay. This is charged. And it doesn't bounce off. I've tried this demo. This looks like I only tried it once, but I've been trying it, probably tried it 30 times now, and it's not working. I think the air is just too humid. What usually happens, and maybe I can find one online to show you, is that the tinsel is attracted to the charged electrophorus, and then when it touches the electrophorus, it becomes charged, and then it bounces off, and it actually stays up in the air, and you can kind of keep it up. I could not show that to you today, so I'm going to call it quits on that and see if I can find a video online to show you that particular thing, but that's what happens when it's been raining for the past couple of days, and there's just a lot of humidity in the air. Okay, that's the last part of the lab, and that's it. Okay, great. I think you saw that. Okay, so you kind of saw the tinsel. That was like my 50th try, but got that one. You kind of saw the tinsel touch this metal and then bounce away. So your job is to explain all of the steps in what I just did in terms of what kind of charge it is and the vocabulary: conductor, insulator, separation of charge, induction, polarization. We're kind of using those interchangeably. Induction with grounding, conduction, and a ground. And all of those terms are things that are involved in this process that I just demonstrated. And you should be able to use them to explain what's happening step by step. You're going to draw pictures labeling the charges in color, and you're also going to explain it using the vocabulary. Okay, and that's the end of the lab. All right, thank you. Enjoy your doing your write-up, and send it to me. Send me a photo when you're done.